So we're going to look at a different way to define a sequence of numbers. What we've looked at up till now has been what's called an explicit formula. An explicit formula says that, look, I want to find the 9th term, the 13th term, the 15th term. You have a formula and you plug in for n, and that n then you're going to plug in on both sides and you'll get the t-nth term. For example, if I wanted to find the 5th term here, t of 5 would equal 3 times 4 to the 4th. A recursive formula is a little different. Recursive formula, there are two parts always to a recursive formula. A known term and then a rule whereby you get from a previous term to the next term. So for example, if I tell you that t1 is 3 and I want to get to t2, well, t2 is going to equal 4 times t of 2 minus 1, or t1. So t2 equals 4 times t1, which is 3, and 4 times 3 would be 12. So for an example, additional example here, suppose you're told that the first term of some sequence is 3, the nth term is 4 times the previous term plus 1. I always like to put braces around for a recursive formula just to remind me it's got two parts. I've got to have a given term somewhere to start with, and then a rule how to get to the next term from the previous term. So if I wanted to find here t2, t2 would be 4 times t of 2 minus 1 plus 1. Well, t of 2 minus 1 is t of 1, and t of 1 is given to be 3, so this is going to be 4 times 3 plus 1, or 13. t2 is going to be 13. So how do I get to t3? t3 again is going to be 4 times t of 3 minus 1 plus 1, or 4 of t2 plus 1. I found t2 to be 13, so that's going to equal 4 times 13 plus 1. Let's see, that's 53, I think. So again, here's an example of a recursive formula, and we have two parts. We're given a specific term, and note I've changed my subscripts here to be the n plus first term compared to the nth term. The n plus first term is one more than the nth term. So how do I get to the next term? I take and multiply the previous term by 2 and then subtract that product from 3. So if I wanted to get, for example, what is t5, I know what t4 is, I would view t5 as t of 4 plus 1, which would be equal 3 minus t times 2 times t4. So that's 3 minus 2 times t4 is 8. So that would be 3 minus 16, or negative 13. Continuing with the same example here for a minute, we went forward. We said, okay, let's suppose we got t4, we got a rule to get to the next term, and we found t5. Well, suppose we wanted to go backwards and find what's t3 here. Well, to find t3, I know what t4 is. So let's see, if I set n here equal to 3, t4 is going to equal 3 minus 2 times the previous term, or t3. So go ahead and plug in what t4 equals. So I get 8 equals 3 minus 2 times t3. Solve this for t3, you get t3 is negative 5 halves. Perhaps the most famous recursively defined sequence, at least in high school mathematics to some degree, is what's called the Fibonacci sequence. And the Fibonacci sequence comes up in the golden ratio, comes up in many places. And basically it's a pretty simple looking sequence. Etc., etc. question is, how do you get from one term to the next? Well, Fibonacci sequence is actually not going to define the next term in terms of just the previous term. It's going to define the next term in terms of the previous two terms. So if I set that up, then again I'm looking at t1 equals 0, t2 equals 1. The nth term, or if you want to call it the n plus second term, is the n plus first term plus the nth term. So in other words, to get to a term, you have to add the previous two terms. So if I look at that up here, 0 plus 1 gets me 1, 1 plus 1 gets me 2, 1 plus 2 gets me 3, etc., etc. So I can define a sequence in terms of two terms, two consecutive terms, and how do I get to the next term from some combination of those previous two terms.